So in these lessons, we are covering some basic review from Algebra 1 with a little bit more difficulty in the types of problems. So we're going to first talk about properties of numbers, and then we're going to talk about algebraic expressions, and then solving equations. At the beginning of your table of contents for the whole notebook, we list all the chapters for the year. You just need to fill in 1 through 16, which is going to cover everything from chapter 1. The table of contents for chapter 1 is going to include all of these concepts, but for today, we're going to cover everything from 2 and 3 all the way down to page 10. So 2 and 3 is for the real number system, and then all the other concepts are 1 per page. You're also going to want to number your notebook, starting on that page 1, 2, and keep going. I would just do pages 1 through 16 so far because that's what we're going to be covering in this set of notes. So the first thing we're going to discuss is the different types of numbers, okay? And then the real number system. The first one that we're going to discuss is natural numbers. Natural numbers are the numbers used for counting. So that would be your counting numbers, 1, 2, 3, 4, and so on. So that's what you'll write in the example. The second type of numbers adds only one more digit to that set. It still includes all the natural numbers, but it adds 0 to this one. So the rest of it is exactly the same as the natural numbers. So the whole numbers does include the natural numbers. When you get to integers, integers include the natural numbers and 0, but it adds one more element. That element is negative numbers. Okay, so now it does include 0, but it's not just the positive numbers, it's also the negative numbers. Okay, so that's one more set or one more dimension added. And then the larger set of numbers are rational and irrational. Rational simply means any numbers that can be written as quotients of integers, meaning the ability to write them as fractions. Okay, so this introduces fractions, and it includes fractions that can be written as terminating decimals or repeating decimals. So this adds our dimension of fractions and decimals. So very common fractions you're familiar with: 1/2, -1/3. Keep in mind that this one is a repeating decimal, okay? And it can include other repeating decimals like 0.6 repeating. That's the equivalent of 2/3. Any digits that can be written as a fraction, or if that fraction can be divided out to produce a terminating or repeating decimal, then that is also an example of a rational number. It can also include whole numbers, and the reason for that is because whole numbers can be written as a fraction if we write them over top of 1. And then the last group of numbers is irrational numbers, and this is where it gets a little tricky. These are numbers that cannot be written as quotients of fractions, meaning there is no fraction that represents them. Therefore, there's also no decimal that represents them. So when would that happen? Well, that would happen if the decimals never terminate or repeat. Now, the other thing that it includes in this category now is square roots, but we're talking specifically about square roots that are not a perfect square, because the number, for example, square root of 4 would equal a rational number of 2. Okay, so irrational numbers have decimals that never terminate or repeat, or they have perfect squares, okay? That do not have perfect squares, okay? So this would include numbers like, let's see, square root of 2, right? If you type on a calculator, and I'll just do that real fast, if you type the square root of 2, let me turn it sideways, the square root of 2 you're going to get 1.41421356237371, right? Not a perfect square, okay? So that would be an example of an irrational number. Pi is another example of an irrational number. If you've ever learned this before, you know that we usually estimate pi to be 3.14, but pi is actually a never-ending number, and it does not have any repeating digits. And there are some other fractions that you probably could find if you wanted to use a calculator that can also be considered decimals and fractions that never repeat and never end. So that's something else to keep in mind as you're thinking about those. So for example, I just randomly used my calculator and I found that 5/23 is an irrational number. There's no series of repeating digits. So you could find them, but you'd have to kind of check them on a calculator, okay? In the next video, we will kind of place these numbers into a graphic organizer to help us understand how these numbers relate